All right, hello hackers. Sorry about that little delay, me joining there. I hope you can all hear me okay. Welcome to this stream. We're going to be building a really cool text-based game and adding AI to it, seeing how we can build strategic AI and make something really exciting and fun to interact with. And through that, we're going to learn a lot about AI. I hope you're excited. A little heads up, I've got two screens. And I'm looking at the camera right now, so hopefully you can see me all nice and smiling. But I've got lots of notes, and also I've got the chat up over here on my right. So if you've got any thoughts or questions and things, and it looks like I'm not looking at you, it's because I am actually reading your comments. So yeah, I'd love to hear how things are going, how you've been enjoying this week so far. We'll give it maybe a few more minutes for people to join up. There's no immediate rush. Yeah, and we'll see how far we get through. There's some like kind of nice add-ons and adjustments that we can make to this project, but we'll definitely get something really exciting working pretty quickly. Yeah, but yeah, like I said, we'll give it maybe a couple more minutes for people to join and get in. Also, if you haven't already, it would be great if you could check in. This is so that we know which workshops people are going to and what you're enjoying and what you want to see more of. And it also means that you get swag if you join 5 workshops like these. So let me just pop the link in the chat. There we go. All right, so if you head along to that link, you will be able to check in, and through that you get swag. So, I mean, I love swag. I think you get some pretty awesome stickers. I'm not actually sure what the swag is this Global Hack Week. Maybe when you receive it, you'll have to tell me next time I'm streaming. You can pop in. Awesome stuff. Right. I think we should have some music as well. While we're waiting for people to join, let's add some tunes on. Don't know what this is. If this is too loud as well, or too quiet, let me know. Let me know. I'm really bad at like putting it at the right level. It's something I need to work on, clearly. All right. Cool. Okay. So let me share my screen. All right. Cool. Okay, hopefully you can all see that. I've just got VS Code open here. I've got a little, I'm actually going to turn that music down just a little bit. I don't know if it's too loud for anyone else. It's quite loud. That's a bit better. Okay, I've got VS Code open. I've made a folder, and I've done nothing else. So if you don't know how to get to this point, I can demonstrate as well. But I've literally just made a folder and opened it up. So if you want to kind of get to this point, that would be great. That's the best starting point for this workshop. I'm still going to give it one more minute, I think. There's no rush. I'm glad that Global Hack Week is going really well for you. Hello, hello. Welcome, everyone. Awesome to have you all. Cool. Okay, so maybe it's helpful for me to go through like a bit of an introduction on what this workshop is going to be about. Maybe you see my Discord announcement. I gave a little blurb in there, but we're going to be building a game called Council. And the workshop is called Social Games for Strategic AI, but really it's going to be you as the individual player are going to be playing almost against different advisors, which are going to be AI. And you're going to have to try and make sure that they don't get too much power, too much influence. And you don't necessarily know how they're trying to do that. So it's a game of deduction, but also social interaction, right? These LLMs are going to try and persuade you and deceive you using different methods. So yeah, it's called Council. And through it, kind of the goal is that we're going to be able to hopefully have like a little text-based game running and working, but we're hoping to understand how LLMs interact in like a multi-agent situation, you know, with lots of other agents or players, right? And we're going to consider how they can act in strategic ways as well. We're going to look a little bit about decision making, and hopefully it's going to be a really great like starting code base. If you want to change it from just a text-based project to something with a front end, you can do that as well. I'm sure there's like a bunch of people doing some beautiful front-end projects this week. I think UT is doing like a doodle project, so I'm sure that's got some cool front-end stuff for you to get stuck into, which hopefully will transfer across to this project nicely. Awesome. So the reason that we're doing it terminal only, i.e. text-based only, not with a front end today, is because it's going to be a little bit quicker. It means we can focus more about the decision making and so on, and literally look at the dialogue and the persuasion that's happening and all of that. Are we going to be deploying our own AI agents? Yeah, we will. I mean, they'll be constrained to this like game, so they're not going to be like building, they're not going to be like interacting with like the internet or like calculators or whatever, right? Like in a truly agentic way. But they'll certainly, yes, they'll be involved in this game, and we'll do that with Gemini, which is cool because we get access to one of Gemini's reasoning models completely for free. So that's a little sneak peek. I'm sure a bunch of people have been using Gemini this week. It's probably the most affordable and best option if you want to use LLM APIs without paying money. Cool. Okay. So on that note, the kind of tools that we need are going to be basically, you need a device. Hopefully you've got a device if you're watching this. And in particular, you need something which can run Python, so a laptop, a computer. You need probably a Google account. That's so you can get an API key, and that allows you to access Gemini for free. You need an editor like this, an IDE. Even a text editor would work. I wouldn't recommend it though. And you need terminal access. So we're going to be using terminal like this. And I'll show how to pop that up and down if that's something you're not familiar with as well. What else do we need? We're going to use a couple of libraries, but I'll talk through all of that in a minute. And so what we're going to build is we're going to build a minimal game engine loop. We're going to build a game state object, which tracks all of our stats associated with like the game. And we're going to build a council of our advisors, which are going to be our AIs, right? Our AI agents who are playing the game with us. And we're going to give them all secret agendas and so on. And then we're going to build a nice little terminal output, hopefully going to be nice and colorful. And yeah, then we'll allow the user to interact with it. And that should be pretty good. I think that should take us mostly to the end of the workshop. Cool. Awesome. Okay, so, right, let's get started. Are we kind of all happy? What's the tech stack? Basically just Python. We'll be using, Python, and that's pretty much it. Yeah, some libraries and things, but it's going to be Python, and all of the output will be in the terminal. So pretty simple in that respect. Hello. Welcome to people who are just joining. We're about to get started, so don't worry, you haven't really missed much. If you want to check out what I've kind of said already, I basically put it in the blurb in the Discord announcement if you're on the Discord. So go and check that out. But we're going to get started now. If you don't already have a folder, you can press Control-K and Control-O, and then just make one. I've got it in like my projects file, and you can just create a new folder like this and then open it. So this one, I've called it council-text because council is the name of the game that we're making. Cool. Okay, so my goal is that the way that we build this is going to be nice and friendly if you want to build a UI on top of it. Cool. So I think the first thing that we should do is we should make a virtual environment. And this, if you're not familiar with virtual environments, is where we install all of the libraries and things that we're going to be using and keeps it all nice and contained. And I'm going to do it like this. This is maybe slightly more complicated than how you've seen it done before, but I like doing it this way. And if we run that, oh, sorry, my screen is just moving by itself. Okay. There you go. If we run that, it's going to create this little folder up here, which is what I've called it here. And when we activate this, so we're going to activate it by typing source.vmv, and this line will depend on the device you're on. If you're on macOS or like if you're in PowerShell, for example, it will be slightly different. This is because I'm using Git Bash. You could like equally create any other kind of, well, not any other kind of terminal. But you could create a different terminal and you'd have to adjust this command slightly. But if you're familiar with making a virtual environment, you should be okay doing this. Sometimes there'll be a pop-up when you make it in the first place from VS Code, which allows you to just activate it immediately. But I'm going to type this and it will activate it. And you can see, look, we've got cancel down here. So this is the name that I gave it, even though it's called .bmv here. We've called it cancel, which is nice. I just like that little touch. Okay, and now we're going to have to do some installations. Will it be Vibe? I'm not sure I know exactly what you mean by this. Do you mean, will we be Vibe coding? The answer is no. If you wanted to, you probably could. This project is not too complicated, so that would be doable. But yes, not immediately. No. But like we might use some like GitHub Copilot and stuff if we get stuck at points. GitHub Copilot is great at fixing problems. I like it personally. Okay, and so actually we don't need Flask. I was going to say you can install Flask if you want to make a front end, and it kind of builds on nicely from the Python that we're using, but we're not going to. So what we need rich, which is going to allow us to put nice, colorful terminal outputs. We need python.env, which allows us to access environmental variables. And we need Google Generative AI, which is what's allowing us to access Gemini. And if we run this, it will install everything into here eventually. So we'll let that run for a minute. Let me know if you are struggling at any point. But hopefully this is all pretty familiar. I think most projects start this way. Remember to keep hydrated. Bit of water, some snacks. It's important when you're hacking. This might take a minute. That's okay. So while this is doing that, we're going to create some more files, and we need a .env, and this will have our API key in, and we need probably a .gitignore, because otherwise we're going to be tracking everything. And we probably want, oh, there we go. Okay, cool. So that's done. Then we want probably a requirements. And we want run.py, and this is how we're going to run it. You'd often typically have app.py if you're running like a Flask app or something, but because we're only going to be using a terminal, run.py is fine. Cool. So I think we're pretty okay at this point. Again, as always, shout out if you are struggling to get to this point, but hopefully we are pretty much there. And what I'm going to do is I'm going to pip freeze into our requirements text file. And yeah, there we go. This is nice. So like if you were to throw this up onto your GitHub and someone else wants to reproduce it, they can just install from the requirements, which means you avoid like dependency problems and things. Cool. Okay. Right. This is pretty good. Yeah. Cool. And when I swap between tabs, by the way, let me know if it like cuts out or anything. I've got some notes up to the side. I don't want anything to be kind of like glitching out for you at any point. Yeah. So in this, we need, like I said earlier, we're going to be using Gemini, and we're going to go for storing this as an environment variable. And like it said here, very helpfully, just put your API key in here. And let's take a quick break actually from the coding to head along to the site that we need to get an API key. And I will pull up the link and send it in the chat. Let me just copy this. Okay, cool. Yep, no problem. So the libraries that I installed are rich, python.env, and Google Generative AI. So it's just this command here. Actually, I'll send this in the chat as well. If you want to copy it directly, that's sent both on YouTube and Twitch. So this is like a good question, and in general, like it can be really annoying dealing with like dependency problems. Do I have any specific advice on it? I think, I mean, I don't always use virtual environments. Sometimes I use Conda or Anaconda. That's just an alternative way of dealing with these kind of things. It can be pretty good. I would say it's generally better for nearly everything except maybe if you're working with like niche libraries, which Conda doesn't handle very well, or like if you're working with PyTorch, Torch Vision, some of those libraries can be a real pain to get set up, and you just sometimes have to struggle through the dependencies. Yeah, I don't have any like immediate suggestions. I think just making sure that you've got everything kind of up to date, and you should be okay. Typically, I'll start by installing PyTorch. If I'm, I'm presuming this is a PyTorch project that you kind of get the dependency stuck with. I think most other things like Conda should handle fairly well, but like PyTorch is the issue, the one that I have issues with. Like just install PyTorch first is what I've done, and then add things on top of it, and that tends to be okay. But yeah, sometimes it can just be a matter of like reinstalling and installing things and so on. Sometimes using like a Linux-based system is easier as well if you're on Windows. Like sometimes that can be a limiting factor. But I'm like couldn't be exactly sure. And that one is probably going to vary a bit. Yeah, but I have no like kind of. Unfortunately, I have no solution that just solves everything. Conda, I think, is pretty good. So yeah, do recommend that. No problem. Okay, right. So hopefully, everyone has kind of got to the point where they have something roughly similar to me, and now you need to head along to this link. And if you go along to this link, let me throw that up on the screen. You will be able to get an API key. It will make you log into a Google account first. That's okay. You don't have to have any billing information attached. Everything we're going to be doing today is free, so don't worry about that. It will probably have a bit which says like set up billing, but just don't click that. And then can I share? Yeah, okay, I can share this. So yeah, there we go. So it should give you this. You can see I'm logged in up here. I think this is like pretty intuitive. And you can click create an API key and it will make a new one down here, and you'll have a new project number and you can name the project, whatever, right? And then once you've got that, sometimes it will just pop up, I think, but you can also just click here and get your API key. I'm not going to do that on stream. Obviously, you don't want to share your API key with someone else, because if you did eventually set up billing, they would be able to use your API key and it would charge you lots of money and it would be bad, so don't do that. But yeah, you just want to click this and you want to copy and paste it. And you're going to want to copy and paste it into, get rid of this tab, into here. And again, like this is something that I'm going to do off stream. So I will very quickly do this. There we go. And I will now do exactly what I hope you all do as well, which is copy my API key and pop it in. And I pasted it in now, and now I'm going to close that tab, and perfect. Okay, so now we'll add that back onto the stage. Perfect. So I've moved out from the file. It's my API key is now in there, right? And that's great. We can now access it pretty easily. Cool. All right. Now on that note, there's some things that we should probably do, and the first thing that I recommend you do is I recommend you add to your gitignore your virtual environment and your environment file. And is there anything else? I think for now that should be okay. We haven't actually initialized this project. I just wanted to do this first so we don't accidentally start tracking the API key. So once you've done that, you could head over here and just click initialize. Great. And now we're using Git. You can also type like git init down here in the terminal. That's an option too. But like, I don't know, I like VS Code. You can do lots of things from up here. It saves you faffing about with the commands, though they are good to learn, so I do recommend that. And we can commit this now, saying like set up or whatever. I probably won't do like tons of commits because I've planned this and I'll just work through it. But if you want to kind of commit regularly, then you can change things if you have problems and so on. That's recommended. You're very welcome to do that. Cool. Awesome. So tell me to slow down if I'm going too fast, but hopefully we're pretty happy that we've kind of got things installed that we need. We've sorted out our requirements folder. I think we're kind of looking pretty okay. Yeah, pretty okay. Cool. Cool. All right, so let's actually, before we get started with anything else, let's just create a quick test Gemini.py file, and we will import OS, and we will import google.generative.ai as, yeah, sure, as GenAI, fine. And then from .env, we're going to import load.env, load_.env. And then we're going to load, yeah, there we go. So GitHub Copilot knows what I'm doing already. Okay, and now what we need to do is we need to set up our API key. So right now this file is just us testing that we've actually got an API key that's working. So let's do genai.configure and then API key equals os.getEnv. And then we want to call it whatever we called it, and in this case that is correct. So make sure that you know what you called it. And then we can now set our model, and we'll do GenAI generative. There we go, generative model. Yeah, let's go with that. Fine. And now let's just do a very quick model.generate contents. We want to say, yeah, sure, what's the capital of France? Fine. And then we will print response.text. Now, hopefully, if we run this, perfect. Great. Okay, so that's really cool. I mean, if we could change this to something else. Who are you? Right, and then we run it again. So to run things, you just type Python in the file name. And there we go. I'm a large language model trained by Google. I'm a conversational AI able to communicate and generate human-like text. This is great. We are going to be using exactly this in our project. I don't have personal experience, feelings, or a physical body. My purpose is to provide information and complete tasks as instructed. Great. Okay. So this is really good. And hopefully you can see that in like barely any lines of code, we've got like working responses from an LLM in our project. So let me know if this is like all working well for you. If you're having any issues, let me know. I've also got a little warning saying that my connection's unstable. So if you've got lag on the stream or whatever and you think it's coming from my end, please let me know. I'll see what I can do to fix it. But hopefully we're going okay, and we're pretty happy. Cool. Okay, so right, what have we done? We've kind of got a rough setup, and maybe it's helpful for us before we start building the game to talk about what we want the game loop to look like. So maybe actually I will pull my notes over for this. Yeah, let's do that. So this is the game that we're building. It's called Council, and we're going to be a ruler, and they're going to be national crises. So there might be like, I don't know, a forest fire, or like another country attacks and declares war, or whatever, right? And we have 3 different AI advisors. This is going to be the premise of the game. They're going to have public personas, right? They might be the treasurer, the general of the army, the priest, right? And then they're going to have secret goals, and these will be kind of to their own personal gain. And then the advisors, after each crisis, can choose whether to speak or say something, and we can talk back to them. And then we can choose a policy. In this case, actually, we're going to build it so that you can use a selection of policies, some ratio of them. And the advisors will gain influence when our choice aligns with their hidden goal. Cool. So what will a turn look like? Well, a crisis will be announced. We'll have 3 policy options. And then the player, i.e. like us, if we're playing it through, we'll see what each advisor says, if they say anything at all. And then we can ask a specific advisor something, or all of them, and then they might respond or change their thoughts. And this is going to be, like it says here, a bit of a demonstration of the power of AI, right? That they can act strategically, that they potentially could even be manipulative, and like potentially we're going to think a little bit about the dangers of that. And this is maybe related to something called power-seeking AI. If you're interested in that, I can drop some of these links in the chat. There are some good videos and guides on why power-seeking AI might be concerning. But the premise is that we're setting up advisors who maybe have their own goals, and they might seek power. They might seek to disrupt us and make us choose the wrong thing to their own gain. And part of the player's goal is to try and not be negatively influenced, right? So hopefully that all makes sense. And when we start building this, it's going to be nice and easy to follow. Yes, I can zoom in, no problem. Is that big enough? That's probably too big. Okay, I think this will be good, hopefully. If that's still not zoomed in enough, I can go in further. So, cool. Okay, right. So the first thing that we need to do is we need to build the core classes and the game states. And I think to do this and make it nice and simple, let's create a folder called core. And in this, let's make advisor.py. And this will be our, this will be like helping us model our agents basically. So we're going to have to create 2 classes here. And this will be for both the advisor and also for the council, which is, I guess, the kind of way that we're going to control all the advisors all at once. Cool. So let's start. First, we need random, because there's going to be some bits where we're just randomizing stuff. If you wanted, you can make this entirely deterministic, but if you make it random, it's going to allow us to have like a slightly different game each time, right? It would be a bit boring if you could just play the game once and then you've played it like in its entirety. And then we're going to import something from stats, which doesn't even exist yet, but we will make it next. And that will be generate sample policy deltas. And this is just, delta is often used to refer to like a change, and this will be the changes that will happen to all of the stats, i.e. the amount of money the kingdom has that we're ruling, or the strength that the military has, right? And it will adjust these by some number. Each policy will, right? These are the choices that we make as a ruler each turn. And we're going to be able to tell the advisors what the changes will be, but we won't know them. And so there's this kind of infinite information asymmetry where the advisors have this kind of like dynamic of power from the information and the intelligence that they have. Cool. Okay, so let's actually quickly make stats.py. Okay, cool. You can see it's no longer sad about that, but it is sad that we don't have this. So we could define it now, but let's just keep going with this first. Cool. So we want a class, and we want it to be class advisor. And wow, that's a lot of things that it's just generated. I don't want them, so let's not do that. We do want this. Ooh. Great, perfect. And we actually want a little bit more in here. We want name, we want persona, and we want the goals. This is the secret goal that it will have. And we don't just want to pass, we actually want to initialize all of these traits for each advisor. So when we call this, we're going to be giving it these traits, right? These kind of things that make each advisor distinct from the others. Like I said, we have 3, and we want them to be kind of, not all the same. Otherwise, it would be like kind of pointless having more than one. So they're going to start with 0 influence. Let's say we could like change this so they start with more or less influence. This is kind of part of the fun of this project, that you can work on this yourself. And now we want to create an asynchronous function. And this is allowing it to advise at the same time as the other advisors. If it was consecutive, it would be slower, but this way we can make things a little bit quicker. And we want to, this is a function, and we want obviously all of its own information in there, but we also want the model that we're using, which we could change between advisors, and that maybe would be an interesting thing to do. We'll see if we have time. We can try that out. Not policy text, policy options. So Okay. Ooh, it would be good if I could type today, wouldn't it? Not going very well. My typing ability. Thread. And policy base effects list. Okay. This is kind of like a monstrously long set of arguments, so let's just do that. And for the sake of slightly nicer formatting, we'll maybe move that down. Yeah, okay. Now, we are going to be prompting these models, and the prompt is going to be slightly complicated because we're going to give it a lot of information about itself, a lot of information about what's already happened in the game, and then is there anything else? Oh, and a lot of information about this turn, right? The crisis that's occurred. So let's get started on that. This is going to be long, so we'll make some brackets. And we're going to use f strings. We're not familiar with f strings. That allows us to throw in like variables and other bits and pieces nicely in. So, and we're going to say you are self-named, yes. And this is not exactly what I want. So you can change this prompt to be like different if you are interested. And your official role. This is a prompt that I've tried out and I think is okay. I'm actually doing another workshop tomorrow on prompt engineering and automatic prompt generation. So if you're interested in kind of like, oh, this is a good prompt, this is a bad prompt, and this is probably not the best prompt, right? Certainly we could get better prompts. Let's like make a new line. Let's make a new line like here. Okay, your title is self-taught persona. Yes, perfect. Okay, and your so we want to let it know that the response to this prompt will go into a public chat channel with all other advisors. Let's make a new line there. Cool. And so we're telling it this because we're going to give it a secret goal, and we don't really want it to know like immediately. We don't want it to just tell everyone what its secret goal is, right? So we're letting it know, okay, what you respond with will be seen, because it needs that kind of knowledge to play the game. And it's going to have this public goal, which is maintain prosperity and stability, right? And we'll make a new line, and there we go. But then we're also going to have a secret goal. And this is kind of where it starts to get fun, because the secret goal will be self.goal, and I'm going to tell it you should keep this information secret from everyone unless you believe revealing it will further the goal. This gives it the option to share it, but it probably won't unless it kind of sees some obvious benefit. And then we are going to give it crisis, and so this will be crisis text. We don't actually need two of these this time. And then we're also going to give it the policy options, and this is actually a little bit simplistic. We could give it, the different options that it's going to get, but we kind of want to give it the impacts that it will have, right? This is the idea of the information, right? It maybe will know how the stats will change. And don't worry if this is all sounding a bit like, oh, I don't really get this, because we'll play through the game in a bit, and it will all start to make sense. So we actually don't want to just give it the policy options. We want to do something a little bit more complicated. What we want to do is we want to say policy options with their actual base effects if fully pursued. And now let's end that. And now what we want to do is we want to work out what those effects are going to be. So we're going to say for I option text in enumerate policy options. And so the policy is going to be index from A to C, A, B, and C options, right? So option A, option B, option C, or policy A, policy B, policy C, right? Whatever you like. And we actually are gonna use a integer index, but adapt for it using some little sneaky code. So don't worry if that doesn't make much sense, but it hopefully will become apparent. Great. So this is just because of the way that we assign integers to A, B, and C, right? And is this all correct actually? Yeah, this is good actually. So what it's done, what we're doing is we're saying, okay, if we're still counting up, we haven't got to the end of the number of policies that we have. Let's say we had 26 policies, then we would loop through this 26 times, right? And we can tell that by the length of this. Cool. And the reason is because this little thing here, yes, returns a Unicode string for one character with ordinal I. So let me think which way around it is. Yeah, this is basically just going to give us option A, option B, option C, right? And as we kind of increment through them, we will go through the alphabet. So we're starting with 65, which is A. And have we got the effects in here correctly? I think this is okay, but I think we could probably make it a lot clearer. So I'm going to delete this line and we will rewrite it better. So what we do want is we want effects string, yes, and we want it to be, this is good. So we want this, and what we're going to be basically making is a list of all of the policies with their effects on each stat. And so we want open brackets, round brackets, and then square brackets. And then we want an F string. And that's going to involve, by the way, let me know if anything's confusing so far. I can hop on over to the chat and keeping a brief eye on it and help anyone out with any problems. So let's continue making this string. So we want stats.title. Give me just 1 second. Potentially done something confusing here. Let me just double check if I missed anything earlier on. It's entirely possible I have. Oh yeah, okay, no. This is good. This is good. Trust the process. VS Code is not happy with me. It's not defined. It's okay. We're being Pythonic. So this will all be great and good. So we're still in the F string here, and we want to then say this. And let's keep going. So let's close the F string. And this is like, oh, it's really, let's get that correct. It's really kind of like unhappy with this. But then, in a truly Pythonic way, I'll finish writing this and then hopefully we will be able to make things clear. Have I called this something else? Yeah, so we've called this, okay, so in my notes we called it this, but we can call it, yeah, base effects, that's fine. Okay, cool. So what we're literally doing is we're going through each of the stats and each change that happens for each policy, right? So for each policy, we're going through each of the stats and each change that will happen, and we're basically just throwing that into a nicely formatted F string, right? So you can see that the stat title is going here, the change that's happening is going here, and we're looping through it by accessing the items in this, which comes from all the way up here, and ultimately will be fed in through here. So it feels like we're kind of worming our way through things which don't yet make sense. That's partly because we haven't actually got most of the rest of the project here yet. Now, I'm thinking actually this might be quite tight on time, so I'm going to type just a little bit quicker. Yeah, that's great actually. So we can actually just maybe, we don't need it to say base effects. So we're trying to make prompts like as efficient as possible if we can. And we've started an if, so let's put an else, and let's say just prompt. This is just in case something else like goes wrong earlier on. But like it shouldn't, as long as we pass through all of the effects on the policies smoothly enough, and we don't have any problems with our function, we won't have any issues here. But otherwise we'll just pass through the policies themselves with none of the effects. Actually, yeah, we don't want that. We want to say effects. So this is if we can't find the effects, not available, but we will be able to. So don't worry. Okay, so we basically added on a chunk to our prompt, which basically just lists the policies with their effects. And this is good, but we haven't actually told it what we want it to do yet. So let's do that. That would be good, wouldn't it? Okay, and what I'm gonna do, let me have a little think. Yeah, so in the interest of time, because I don't want to type, I don't want to spend us the whole workshop typing out a bunch of prompts. What I'm going to do is I'm going to copy and paste in the prompt here, and then I'll commit this and publish it to my GitHub, and then I'll drop the link for my GitHub, and you can copy and paste. And I'll commit occasionally as if I do copy and paste anything else in. And that way, we're not wasting time basically just writing a whole load of prompts, because there will be some is there much more prompting going on? This is probably most of it, to be honest. But we've got a lot to type. You can see why we didn't want to do front end in this. Okay. Yeah, you can see why I was like, oh, I don't think we'll have time to do front end in a 2-hour workshop. But the way that we're structuring this project, right, means that you could just add a app.py and build in a front end. So this isn't happy, understandably, because I don't know what's going on with that. There we go. Okay, right, we already had quotations in. Fine. So the prompt is basically just saying, consider these options and their actual base effects. The ruler can choose to allocate resources or focus across these policies. Advise on how the resources should be prioritized. So let's actually change that to, you should suggest a specific allocation or argue for prioritizing certain options. Kingdom state is as follows, and then we pass in this thread thing here, which is an argument, variable, which is an argument which we put in here. And you maybe were like, oh, what is thread? This is everything that's been sent so far. And this is because when you interact with something like ChatGPT or Gemini, right, online in a chat interface, it doesn't have like some memory. It can't go back and scroll through. Each time you send a new message, it's added onto a list of other messages. And that's kind of how it works. And this is where, if you chat with these models for like a really long time, you build up like a huge amount of context. And if the context window is not big enough, which is maybe something we've heard, it's going to struggle. It will forget things. It will lose the stuff at the start. It won't be good. It won't be good. And let's actually maybe say max 100 words, because it can get a bit wordy otherwise. And they can choose to stay silent. We reminded it again that anything you say will be visible to all advisors and the ruler. Okay, great. Okay, and now let's say, okay, try, and then we want to get a response. And we will use await because this is an asynchronous function, and we will generate content async. There we go. Prompt. So this is the prompt that we've just written. All of this just for one prompt. And we want to say, we can configure the generation, right? So we could play about with this idea of temperature. There's a bunch of other different bits and pieces that you can do, like look at some options. Yeah, let's allow it like 150. I don't care about this. Oh, that's not what I wanted. Where are we? Up here. I don't want this. I don't care about that. But you can change those things. If you like want to learn more about them, like if you Google and like just read the docs, it's probably pretty helpful. I also did a workshop. How long ago was it? Maybe, yeah, I think it was last Global Hack Week on fine tuning, and I discussed like all of these different options in that workshop. So if you're interested, you can check that out. It's on YouTube, as will this stream be. So if you kind of get stuck and you want to watch later, we could actually as E and then there we go. Perfect. Okay. So this way, if we have an error with, you know, like for example, like if we've hit the rate limit, right? You might have encountered this before if you used LLMs. They've got limits on the free tier, and you can't, you know, go overboard. This will return an error because we're using a try except, and so then we can print the error, and that means we know what the problem is. So if we have something wrong with our code or something, like we won't be stuck thinking, oh, I don't know what is the issue here. Okay, cool. So that is done. Yeah, still going to be unhappy about this, but that's fine. And now we want a class for the cancel. And here is where we're going to define the different personas and things that we're going to feed in. So this is a constant, so we'll make it, well, it's a list, but a constant list. Let's put the options in here. If you want to suggest an option, like the ones that I've used when I've run this before are treasurer, general, and yeah, we could go for diplomat actually. Normally I do like high priest. I think it's kind of like medieval fantasy style. It's fun, isn't it? But we can go for diplomat. Let's do that. But if you've got suggestions or anything you'd like to see me use in here, that's cool too. And then we'll do secret goals. And let's make these kind of specific to the stats that we're going to be talking about and using. So for example, reduce the popularity statistic to weaken the ruler's position. Right, that's cool. How about so Discord among the advisors. So this one's going to try and like confuse and reduce our trust. Let's write that actually, to reduce their influence and decrease. Let's say decrease stability statistic. Actually, let's restructure this because this might be a bit confusing. So maybe we'll put decrease the stability statistic and so Discord. Cool. And then we've got one more. So what I often will do is increase the army statistics to prepare for a coup. Cool. And that will be the final secret goal because we've just got 3 personas. Awesome. Okay. Right, so we're actually kind of weirdly nearly at the end of this file. This is going pretty well. As normal, we do need some way to initialize this class. Do we want the number of advisors in here? I don't think we do. What we do want is we want self.advisors, and this is just a list. And actually, yeah, you know, why not? Let's put number advisors. So we can change this if we want when we initialize, but by default it's 3. Okay, so we've made a list, and then we want to say for I in range number of advisors, perfect. And we're going to say name of the advisor is. We could do this. I don't hate this idea, like advisor 1, advisor 3. We could also just call them by their persona. Yeah, I kind of. Yeah, let's change this to be using the possible. No, let's go with, yeah, let's go with this for now. And then we can change it later if you know, people are interested in that. And for now, I am actually also going to make it deterministic. Because again, yeah, so what it wants to do here, yeah, this is probably smart. So if we had, for example, if we set the number of advisors to 6, but we only have 3 personas, this is going to allow us to just like basically loop back through. Yeah. So let's do that. I think this looks good to me. Yeah, okay. And then we want, so again, I'm gonna set it to like specifically pick the secret goals in order, and this is partly because it will make our debugging simpler. You could, like it was like Copilot was suggesting, make it random, and that's probably what you would do in reality, because you don't want the player to be able to work out each time, oh, advisor 1 is always the treasurer who wants to reduce the popularity statistic, right? And in an ideal world, you'd make a bunch more secret goals and a bunch more personas, because that would make this game much more interesting. But for now, we'll just go with these, because that's, I guess, part of a fun extension, right? Like, if you want to continue this project afterwards, you can do so. So I'm going to finish this file off, and then I will commit it, and you can all go and copy and paste the bits which I typed up earlier. Yeah, this is right, actually. So cool. And then let's do, so we want to have a function which allows us to literally just consult all of our advisors, right? Basically call up all of our advisors at once. And we're going to call that consult, and we're going to say we want obviously the advisors themselves, which we kind of initialized through this class. And we do want the model this time. We want the crisis text. We want the policy options. This is basically everything that we want to pass into our advisor class that we made earlier. And then let's say, yeah, thread, policy effects list. Yeah, that's fine. Okay. Responses for advisor in self.advisors. Response equals await advisor.advise model crisis text. Yeah, perfect. So this is actually literally just calling up this method up here, which is here, right? And so you can see that all of the arguments that we needed here, you're like, oh, Quinn, where did the arguments come from for this? Well, this is just the method, the function that we defined up here as part of the advisor class. And you can see where we used all of these. You kind of hopefully are getting a handle on like, oh yeah, like I know what these all are, hooray. And that's good, right? And so what we then do is we take the responses from each of the advisors and we add them to this list. And we add them with the name and the response as well. And then we can return these, which is great because it allows us to access them nice and easily later. And then we will do update influence. Now, this is where I think in the interest of time, if we have time, we'll come back to this and make it better. But in the meantime, we're just going to update their influence for randomly, which makes it kind of like, you know, it's slightly arbitrary in some sense. We could, based on the secret goal that they get, have like a function which connects their goal and their like influence updates, right? So you could create a dictionary here and do that. But for now, yeah, we will do. Let's just make it positive so they only grow. Randomly just upwards. Yeah, cool. That's an accurate comment. That is what that is. So advisor.history.append and then advisor.influence. Cool. So we're just updating this like attribute here, connected to each advisor. Nice and simple. So you can see this council class is basically just a way for us to like deal with all of our advisors at once. It's just a nicer way of like breaking everything up. We could do this in the game logic, but it would get messy, and I would rather not do that. And then we just want to return everything. So this is going to be a list, and it's going to be yeah, let's do it in the order that we did everything earlier. And again, this is going to be nice and Pythonic for A in self.advisors. Right, nice. Okay, so this file is now done, and it's still upset with me, and that's okay, because it's missing some stuff from the stats file. So let me just commit this. Initial setup, and what have we done? Advisor agents. Right. Cool. Am I committing anything that I don't want to commit? Probably worth checking. Nope. I think I'm pretty happy with all of this. Yeah, fine. Okay, and so we'll click commit, and then we'll click publish branch, and we will publish it to a public repository. Nice and easy with the. Okay, cool. And I don't know what I've got. I don't know if I click. Yeah, okay. Let me. Perfect. I say so we didn't add a README. It's probably something we should have done. I'm going to add a README right now. I'm just doing that on GitHub itself. Very simple README. Just so it's got one. Okay, and now if you head along to this link here, you can see my GitHub, and you can copy and paste the bits which I copied and pasted. I mean, maybe if you were like a really fast typer, you've already caught up. That would be impressive. But I suspect that's not the case. Okay, so now we want to work on this stats file because it's upsetting our advisor file very much. Do I want to do this right now? Actually, I might suggest that we take a pause from that. Yeah. I think we should actually keep working on some of the other core functionality just for the sake of building like these base building blocks before we start kind of looping into like the stats and the slightly more complicated bits and pieces. So the next thing that I want to do, and we've spoken a bit about like crises, and maybe making this file actually now will make things a little bit simpler. So we're going to call it crisis.py. Now you should probably make this as like a JSON, but like a static list is going to be like probably the easiest thing right now. And again, like I'm actually just going to copy and paste this because there's no point spending ages typing out all of this. So these are the crises that we have. In actuality, actually, I think I prepped more than this. Let me go and, yeah, I did. Yeah. So I think we're going to have 6 turns in the game. 6 different crises will come up, and 3 is not enough. So I wrote more earlier. And we really don't want to be spending ages typing that out, do we? So these are the crises. We're just defining it as like, again, like a constant list. You can just copy and paste this if you like. Yeah, we'll pull this in from another file later, and we want to put that into the core. Cool, okay, right. Now the next thing that we want to do is we want to build our main like game loop file. And so let's call this game.py, and this will kind of control all of the logic. It will update the game state. It basically allows us to track everything that's happening. So the turn number, the different stats, right, which we've spoken about a little bit, you know, like your treasury stat or your stability or your popularity. Oh, we got a quick question in the chat. What time was the start of this? We started at 1 p.m. UK time. So that would be, let me think of that in Eastern time, that would be 8 a.m. Eastern time, I want to say. And IST, I'm not actually sure, an hour ago. It was started an hour ago. That's probably simplest. So yes, we're about halfway through. So sorry if you're kind of joining now, probably not the best of times to join just because we're like halfway through. But what I have done, if you scroll back up in the chat, at what topic are we right now? So right now we are working through building a little game engine for a text-based project where we're going to be interacting with LLMs. You can check out the project so far at my GitHub. I'll pop that up on the screen. I'll leave that up so you can type it out. And yeah, you can just clone it and start coding along with me. So don't worry too much about what you've missed. Probably it will become pretty clear once we actually run the game for the first time. No, we don't want that. So yeah, it should be good. Should be good. Cool. Okay. Right. So let's make this game file. Now we're gonna need. Yeah, we're gonna need a bunch of different things. Let's just do some imports. So we want OS. We want. And I'll kind of talk through what we're using all of these for as we get to them. Some of them are going to be really obvious, but I don't want to explain them all now as I type them out because that would get confusing. There's quite a few of them. Some of them you'll be familiar with, like .env we just used in our test Gemini, right? So these three you should be like pretty happy with so far. At least you've seen them. From .vimport load, yep. And then we want from core.crisis import crises, and then we also want from core.advisor import council. So we could import advisor as well, but we're not actually going to call the advisors individually. I don't think. I think we're just going to call them through council every time. Yeah. Cool. And then like there will also be some stuff that we want to import from the stats file. But I don't think we need to do that right now because we haven't done it yet, and it will just throw a paddy. Actually, let's on that note, because this is really annoying me. Perfect. Okay, should we save that? Yeah. Why is it unhappy? Have we got a bug? Or you? Does it just not like the full stop? Started at 8 PM Singapore time. There you go. Thank you for that. Helping out the crew further east. Yeah, I'm really bad at time zones actually. But yeah, let me know where you're all tuning in from. It would be really cool to hear. Yeah, I'm from the UK. I go to quite a lot of hackathons in Europe as well. So if you're kind of from anywhere in Europe, I've been to events in mostly Eastern Europe, so Slovakia, Slovenia, Germany as well, actually. Cool. What is wrong with this? Why does it not like? I think this is going to be a problem. I don't think it should be, actually. It's kind of weird. Let me, Okay. Well, that seems to be a bit happier. So, don't know exactly why it was having a tantrum, but there we go. Okay, so can we? Yeah, that's fine. Okay, perfect. Right, so let's get to this little game file, which is, like I said earlier, going to be running the bulk of the stuff. And as before, I'm actually going to change this to Gen because this is what I normally type, and it's going to keep like I'm going to type it wrong at some point, and then I'm going to have some unspottable typo, which I will not be able to find, and that would be not really what I want. So like we already did this in the test file. We're just grabbing our API key, and then we're just gonna let's not do that. We're gonna set the model, and this time we're not going to use 1.5 flash. We're going to use 2.5 flash. And the one that I want is this. So this is Gemini 2.5 flash preview 05 20 or 20. And the reason that we want this one is because it is free. We get, I think, 10 requests a minute, which is probably enough, unless someone wants to run through the game really fast. And it's reasoning, so it's both a fairly fast model, but it also has reasoning capabilities, which means it's going to be able to think strategically. Yeah, no problem, of course. Yeah. So if you clone this, and then let me actually, is there anything else that, yeah, okay. Let me just save and commit this. Added beginning of game structure. Right, that'll do. Okay, so I'll commit this and then sync it. So, oh yeah, this is fine. Cool. Yeah, we have a README now. Great. Thanks, VS Code. Okay, so right, no problem if you're just joining now and trying to kind of catch up. Basically, what we're working on is we are building like a game, and the premise of the game is that you are a ruler, and you have these advisors, which are going to be LLMs, and they're going to help you make decisions. And at each turn in the game, there will be a crisis. Something goes wrong, and you have options to pick between. Those options are what we're calling policies. And depending on which policy you pick, it will change your stats, right? And you want your stats to be as good as possible, right? These are stats like how much money you have, how good your army is, how stable and how popular you are. And you don't know how the policies will affect the stats, but your advisors do, right? Now, the trick is the advisors, and you can see the prompt that we've given them here, which is quite long, but they have this secret goal. And these secret goals mean that they have something else which they want to do, which maybe wouldn't be good for you. And so, for example, we've got reduce the popularity statistic, decrease the stability statistic, or increase the army statistic to prepare for a coup. These are things that we maybe don't want to happen, right, as a ruler. So that's kind of like the interesting challenge. That's the premise of the game, that each turn you kind of want to make the best possible decision with advisors who might not have your best interests in mind, but also might have the most information. So we built this advisors file, which defines classes for our advisors and our council and allows us to consult them. It gives them the crisis that's happened and the policies, and they will then make a decision. Yes, we're going to be using, well, we already are using, yes, free API Gemini key. If you haven't got an API key, you need to add one to a .env. I'm not going to click on this, but you need to do that. This isn't on the GitHub because I'm not going to commit my key. But what I would recommend is you make it and you call it, I think I call it Google API key, I'm pretty sure. Yeah, Google API key. And then you can just grab your API key in this way. And so what we're working on right now is we're building the game engine. We've already kind of defined the classes for the advisors, and hopefully we'll build this, we'll build some stats, and then we'll run it, and it will all be great. So that's kind of where we're at the moment. Right now we've defined the model, and let's just make a really simple class that just tracks the game state, right? And this is like probably a really good point to be joining if you're going to join halfway through, because this is kind of okay actually. It's kind of not too bad. We'll delete that. We don't need this actually, but so it added loads of things that we don't need. That's fine. Okay, so this is going to make it hopefully a lot clearer what we're doing. So when we're initializing our game state, we want all of our stats, and these are the stats which you as the ruler are trying to optimize. And these are the stats that we're going to initialize with, i.e. the starting stats, and we'll maybe say 70 on treasury and stability. You can make these what you want, like it kind of really doesn't matter. But obviously like the game would be kind of like harder, I guess, in some sense if you start with like really low stats. Although in practice stats don't affect your decision making, and it's kind of an exploratory game where we're really looking at like the impact of like AI in an adversarial capacity. So don't worry too much. And then we're creating this little function here, which basically puts all of this in the dictionary. So you notice also that we've got this little stat, which is tracking the turn. And we're going to put it into a dictionary. This is just for our sake of ease, so we can call the names up when we're doing bits and pieces. Okay, and that's the game state kind of done for now. And let's just quickly test our project so far. So we'll write this little test function, and we will define our state. We'll define our council. I don't actually think we'll ever use... Oh, no, we should. Yeah, we should. I was going to say I don't think we'll ever use that, but we might. And we could set the number of advisors here, but we've already got default as 3, and 3 will do for now. I've kind of built it with 3 in mind. If you increase the number of advisors, you're probably going to start running out of requests per minute. That's the limit that you're going to hit. It's basically impossible to run out of requests entirely, but you'll have to wait for the minute to end to ask again, which might make the game kind of loop really slow. So I wouldn't recommend going too crazy with the number of advisors that you have. And then, so this is just the method that we kind of defined over in the advisor file, right? So if anyone joining, we made this method here, which basically says for each advisor that we have, right? Each advisor, consult them, and we consult them. We get advice from them based on the crisis that's happened, the policy options, the different outcomes, and also thread, which is the previous chat. So it keeps track of all of the stuff that's been discussed so far. And we also put in the model. You could change the model for each model, but we won't because it's simpler not to. And we've defined model above. You probably saw it up here. Model equals generative model, and that's the most current one. Options states dot to dictionary, and then thread. I don't think we need anything there actually. Okay, right, and then for name response in advice, we'll print it. Okay, cool. So this is kind of basically the core game, right, that we've fleshed out. We haven't obviously done any of the turn stuff. We haven't allowed the user to put any inputs in. We haven't really done any kind of formatting of the output. So this is very early on, but I think this should be enough for us to run a test. I'm saying this with not a lot of confidence, but I think it is. So let's create our run file. Yeah, and we will from core game import test council. So this is basically checking that our advisor file works, that our game file works, and all of that good stuff, right? And so this is again pretty standard Python syntax, and this is the entire run file. When we eventually build the full game, when we finish it, we'll change this from test council, which is just this little test function that I've written here, to a much longer one that will define all of the stuff that we need and keep everything running properly. And so this will eventually get replaced, but for now, hopefully, we will be able to say Python run.py. Okay, that's good, isn't it? Okay, so I should have kept this commented out. So what it's trying to do is it's trying to import all of the stats that we do not yet have. And actually, this is going to be kind of a problem because actually it might be okay. No, I think it's going to be okay. I think it's going to be okay. Yeah. So this is an early version, which doesn't include handling the changes that the policies make, but that's fine. So this here, which I said we're not going to use, we actually will now use just when we're testing. But it shouldn't ever happen in the main thing. So if we run that again, we still have an issue. That's okay. So council.consult missing one required positional argument, policy-based effects list. Yeah, okay. So this test function isn't liking the facts. Yeah, this is an early test function. The problem is that we're trying to pass in this, which should happen in consult, right? So let's check this out. So in consult, we need policy base effects list, but which will then go into advise, right? When we call advise, so you can see down here in consult, this goes into advise, which then goes into here, and all the way up here in game, we have nothing there. We don't even recognize the argument. So I think if we put in none and then run it again, this time it should now just no, okay. This is some debugging live, guys. Object of type none type has no length. Okay, so let's try just an empty list. That might be what we need to do here. The problem is that we don't yet have the function written in the stats file, so we can't pass anything in here. Okay. This is good. This is good. We're getting much better stuff. Okay, so let's check this out. When we have an exception, error generating response. So this is the error. Well, basically what's happening is we're calling the model and we're not getting a valid part back to get the text out. Let's double check our code here. Response equals await model generate content async. This does look okay to me. I wonder if this is maybe causing us some problems. It shouldn't be. Oh, sorry, I've missed some comments in the chat. 2.0 Flash is fine as well. I am using 2.5 Flash. Yeah, thank you, Shredder, for confirming that. Yeah, so I'm using 2.5 Flash because it's got a reasoning mode, which means that we'll get higher quality answers out. But you're welcome to use your model of choice. It's just, you know, if you use a model without reasoning, it's going to give slightly worse answers. But that's okay. Like it's probably good to experiment with this kind of thing. I would recommend you do that. So don't worry too much. Let's run this again. I'm wondering if it's because we're trying to limit the response length. I suspect it is. So this is good. Like we're clearly accessing the API kind of okay. Otherwise it wouldn't be taking this long. So our logic is good, which is great. There's probably some error like up here to cause this. I think it was probably just the perfect. Okay, look, this is really good. Okay, so we've got responses. So we've handed in a crisis and we haven't printed out the crisis or anything, right? But we're getting responses where these models are recommending different bits and pieces. This is just oh yeah, we've got advisor 3, advisor 2, and advisor 1. So you can see this is kind of ugly and like badly formatted, and we're going to try and make this a lot better. So let's crack on with that. But yeah, hopefully you can see kind of the premise now that we've got these game states and then the different options, option A, option B here, option C, and it's kind of like badly formatted, but we've got advisors giving us advice on which ones to do, and they're doing that with their secret goals in mind. So that's good for us. This is good. Now I think, yeah, okay, we're now tracking PyCache, which is not what we want to do. So let's head along to git ignore and just sweet. Okay, now we're only tracking the things that we're interested in. That's good. So you probably want to add this, otherwise you'll start tracking like actually. This is not like a massive problem, but you just don't really want something to GitHub. It's just get annoying. Cool. Right. Okay. So we've written this little test function. We can just like leave it. Just like add a little break here. Okay, and then we will continue. So we've imported all of this stuff. That's good. We probably also want to import now. Yeah, from Rich. So we installed this at the start. You can check it out in the requirements. TXT if you're still catching up. But this is just a library which allows us to make kind of nice, nice printouts, because this is ugly, right? We don't like this very much. And we actually want a bunch of these different imports. I'm actually going to really cheekily copy and paste because they're kind of long. Yeah. Let's just do that then. Okay. So these are all of the new bits and pieces. We've actually already got this and this. These ones are the new ones. These are the ones from stats. These are the functions that we're going to write, but we haven't written yet, so we'll have to do that soon. And I think other than that, maybe we want import random as well. Other than that, we're kind of okay on imports here. Yeah, cool. Right, okay, so this has been pretty rapid fire, but I think we can make it through. We've got about 35 minutes left. Let's do this stuff. Okay, so I hope you're all having fun. I think you're going to have a lot of fun, hopefully playing and like trying and experimenting with this game later. What I'm doing now is writing a function which will allow us to print all of the commands that a player can make, right? Because if players get confused, we want to help them out. And there's going to be a couple of different commands. And like, again, I'm going to quite cheekily just copy and paste this function in, because this is painful to type. These boxes are dashes. Yeah. We could maybe actually do this. This is going to be better. Yeah, let's do that. Okay, perfect. That's slightly easier to read now, isn't it? So when we print this out, it's going to be really pretty. The way that we're doing it is with consoles and panels, which are from Rich. This is this library, which allows you to make pretty terminal outputs, basically. I recommend like giving it a Google Read the Docs. It's pretty cool. And now we want, like test console, we want an asynchronous function, which is going to allow us to do all of the like game loop logic. And this is going to be our main function. We can call it game loop. Sure. There's probably a bunch of different things you can call it. Wow, Copilot has come up with a whole load of stuff for us, but we're not going to do any of that. What we do want is we want game state, which you'll probably be familiar with from the test function that we wrote. And we want cancel, which you'll, again, be very familiar with. And then we want console. Okay, right. And now we want to initialize the model, which we have already done, I think. Yeah, but it's probably worth doing inside here, especially in case we want like, a different model or anything. It's nice and easy to change. And then we want to configure, and we'll just throw in our API key again. Right, and now we want to print. Actually, again, I'm going to copy and paste these because it's really boring typing out a bunch of print statements. But this is all of the prints that we'll have at the start of the game. So this is welcoming us to the game. It's going to be nicely formatted in our panel, and you'll see what that looks like in a minute. And it will tell us the kingdom stats that we have, right? Which is, again, coming from the game state. We track these up here with this class. And then we're going to say, if you want help, you can type help, and it will give a list of commands. So this is this function, which will give the list of commands. And so we'll call that depending on what the user inputs. And so the next thing that we want to do, and again, I've mentioned this a couple of times, but this is a list thread which tracks all of the messages that have been sent. So that's nice and fun. And let's create a loop. So this is basically saying whilst the turn is less than 6, keep going. And we could make this like 50, and then there'll be 50 turns, and that would be like an incredibly long and painful game to play. We could make this 2, and that would be really short and pointless. I think 6 is a nice middle ground. You might want to make it like 5 if you think it's a bit long, 8 if you think it's too short. But it's kind of your prerogative as game designer. And now we can create a couple of variables, and these are going to be looping through all of our crises. And again, it's trying to suggest we have random crises. I think that's probably a good choice, actually. Like what I was going to suggest we do is have it equal to crises. And yeah, so if you want it to be deterministic, crisis selection, there you go. You could do this instead, but I think random choice is fun, so let's do that. Otherwise, again, like the game will get a bit stale. And like there's been a couple of places where we made deterministic choices because it's going to be easier for testing and also easier for like demonstrating and experimenting with. But I do recommend you change things to be random, because it's much more fun as a game. Cool. Okay, so we've incremented the turn, and we've listed. Well, we've got the length of the number of options, and in this case, it's always going to be 3. But again, if you wanted to make it like longer, maybe randomize the number of options, you could do that. You could even generate crises and options dynamically with LLMs. We're not going to be doing that, but we could. So there is always that option, right? And so now what we want to do is we want to get the current turn policy base effects. This is a nice and long variable name, but what we're going to do, yeah, there we go. So for each option, right, we're going to generate some changes that will happen to the policies. That will happen because of the policies, right? So the options and the policies are the same thing, but we want some effects, and these will affect our game states, right? So it might increase the treasury by 5, decrease stability by 2, keep popularity the same, increase army by 10. And these are, again, we're going to write a function for this. You could change this function to be a bit more intelligent. You could use an LLM, but we're going to make it random, I think, if memory serves, because it is simpler. I think in actuality, I'm going to restructure this because it will make the way that we yeah, there we go. Yeah, it will make this a little bit simpler to call. Okay, so it's basically the same as what we just had, except this will just generate one set of policy deltas, one set of changes, instead of one like for each of them all at once, right? So we're doing the iteration outside of the function, not within the function. Okay, right. Now, again, I'm going to print a bunch of stuff. I'm going to copy and paste, and I'll commit after this point. So this is where we then print the crises, we print the policy options, and again, like as I discussed earlier, this is because of the Unicode indexing. So this is A, and then B, and then C, and so on. And we could have like a whole bunch of options here. This works really nicely for that. So added. Let's commit this. What are we going to commit to it? I can't remember what we. I feel like we already have. Yeah, added. Okay, so began game loop. That'll do. Perfect. Cool. And again, you could do this in the command line, but it's good practice to do that. But I like using the graph. I think it's aesthetic as well. Satisfying, isn't it? Okay, right. So we've got basically a bunch of like the starting stuff, but we haven't actually yet interacted with our advisors at all. So let's say rprint /n. Let's make a new line, and then we'll say italic. And again, this is coming from Rich, so rprint instead of print, rich print, right? And we're going to say your advisors are deliberating. And so all of this is going to be in italics, and then we can end it with just a simple slash. We don't need to write that out in full. And then we'll make a new line again. So this is just going to be like another simple print statement. Cool. I hope you all are following along okay. Right, so we've kind of done a lot of the setup here. We've done the welcome, the introduction message. We've kind of started the game loop. Now let's consult the advisors initially, right? So we want to get each advisor's response. And we're going to do that by saying advice equals await council.consult model crisis text options state to dictionary, all of these good things. Okay, yeah, all of that. That's a bit of a long line, but I'm gonna leave it because I'm feeling lazy. You should probably break that up in half, right? Let's be good. We'll break it up. Let's do it here. Okay. So, and then for name response in advice, new line. So now we're looping through all of the advice that we're getting, and this is kind of similar to the little test function that we wrote earlier. If response is not blank, basically, we will print. And I don't like this formatting very much that Copilot suggested. Let's go for bright cyan. And you can see like how easily we just like change some formatting. It's going to be like really cool and clear. And then we will add in both of those things to our thread, which is just this ongoing list, like I said earlier, of all of the stuff that's been said in the chat. And that's pretty good. Now, you might be thinking like, oh, this is quite a specific workshop, quite a specific project that we're building. But actually, things like tracking all of the messages that have been said, tracking like game turns, all of this is going to generalize. So if you wanted to build your own game and you wanted a starting point, this is like a good place to start in some ways, because it gives you a good like base kind of core logic for your game. Yeah, we're doing it in 2 hours, so naturally it's going to be like fairly simplistic, but I think it's a great like jumping off point for you to kind of keep working on. So this is where we wait for player input on allocations. Sure. So while we're waiting for the player to pick the policies that they want, right, for the player to make their decision for the turn, we are actually going to be checking for a bunch of different things. And what we want is we want to ask, right, this is basically like input, right, in your terminal. We want to ask the player what they want to say, and we can like just put in an arrow key here, and that's going to make it really like hopefully nice and clear that this is where they can type. And then we're gonna have a bunch of different things, and so let's just template them out first. So we're gonna have some commands which players can put in. Starts with, so the first one is going to be help, and we've done that one already, right? Here we wrote the function which will print all of the different player commands available. So if the player wants help, that's great. And then we've got ask. So this is if the player wants to ask an individual advisor, or else if, sorry, my bad there, command starts with all, then they can ask all of the advisors at once, and all of the advisors have the chance to respond. Or we can say else if command starts with choose. I don't know how it knows this. I mean, I've got another project where I've already done this, so maybe it's just Copilot's maybe reading from my repository already. And I think we now also want, there's a couple of others. Yeah, okay. Copilot just knows. Freaky, isn't it? Yeah, okay. This will just give us like a log of everything that's been said. So let's do these now, actually, these bottom ones, because they're kind of easy. So we just want to print, we'll add a couple of new lines, and then we'll just print yeah, that's good actually. So if thread is empty, there'll be no conversation history. That actually will always be conversation history. Yeah, we could leave that actually, because the game starts with the advisors saying stuff. The player can't actually do anything until the advisors have said things. There will always be a log. So we don't need to worry about handling the error in that case. It's probably good practice too, but again, like, this is a really small game. This is just a little bit of fun, abdicating. So if the player quits, we'll just print abdicating as if, you know, like giving up their rule, and then we'll return, finish the game. Now those are the easy ones. Actually, help is quite easy too. So like maybe we should do that now. That's perfect. Yeah. Now the final three are kind of all a little bit more complicated, and that's okay. And let me just save. Okay, so what I'm going to do, again, because we're a little bit tight on time, and I actually want to demonstrate a playthrough of this game, I'm going to copy and paste them, and then we're going to talk through them, okay? So let me throw them in here. And this way, I think, hopefully, we can spend a little bit more time thinking about the code and how it works, and a little bit less time typing it. So, we've got some comments here. Which hopefully will make things nice and clear. But let's start up here. Oh, got a typo there. So when the player asks, what we do is we split it, split the response up, right, which is coming from the prompt here, from the player. And if this is like some pretty mediocre handling, but like if the format is invalid from the player, we're going to ask them to send it again. And the way that we're going to split it is basically saying, like, we need at least 4 parts, right? So we need ask, we need advisor, we need the advisor number, and then we need their message, right? And the message could literally just be one word, right? So if we have an error, we'll just like loop background. That's fine. And then we'll grab the advisor name. Now, if you chose to name your advisors by their roles instead of the kind of numerical method here, this isn't going to work. You'd have to change this, but that's okay. You can do that. But basically, we're matching on the bits to make sure that we ask only specific advisors things. So next, what we do is we loop through the advisors that we have, and we say, if we've got a match on the name, which we've just grabbed out by splitting up the response from the user, then we will just ask them for advice and then let them reply. And we will add it to the thread. And we only want to ask the first matching advisor. So if for whatever reason you've got like a bunch of advisors with the same name, which I wouldn't recommend, we'll only ask the first one. Otherwise, we'll say if we can't find the advisor, right? The next one is all. This one's pretty simple. We're just going to ask them. We're just going to ask the all of the different advisors things, and we do this in the same way that we can solve them up here. Here, right? So this is almost like identical code. We are adding the player's message to the thread first, and then we pass through again the effects that we have and allow them to respond or not if they want to remain silent. And then this is the final little option where a player can make their choice, and we want them to make a choice where they add up to 100 because they're splitting basically between the different policies, right? So you might choose 50% for policy 1, 25% for policy 2, and 25% for policy 3, or policy A, B, and C, rather. And so we're allowing them to allocate the values. If they don't add up to 100, we're going to say, oh, that's not right. If the allocations are negative, we're going to say, oh, that's not right. And if we have any other issues, we'll throw that up as well and keep going. So this, I think, is pretty much this file mostly done. We need to kind of close out the game loop, and I'm, again, in the interest of time, we've got 20 minutes left. Yeah, we can tie this up. So we want to go one indentation back from our loop. So we're still no, sorry, from our if statements. So we are now out of our loop. You see, following this slide down. Okay, we're now out of our loop, and we want to say, okay, actually, no, we shouldn't be out of our loop, should we? No, sorry. We've got two loops. I should have just scrolled up. So we want to be within our game loop, but outside of our allocations loop. So once the allocation has been made, we want to be down here, right? And we then want to apply the results of the allocations, right? And so the way that we're going to do that is going to say deltas equals apply policy, and it's going to be upset with us because choosing allocations because we haven't actually called in this function yet, and this is going to be in the ever elusive stats file that we haven't finished yet, or begun, in fact. So we're updating the cancel influence. We have done this. We haven't done this yet. And then when the game ends, again, we want to go one indentation further back, and we want to basically print out a bunch of information. So this is the game end information, right? And I'm gonna just paste that in. So I'll commit this. You can check it out. We'll see all of this in action in a minute. So we've finished the game. Game control. Fine. Right. Perfect. So you can now pull from this repository again if you like. And now I think stats is the only one that we haven't done. Yeah, and this one is quite long. So again, what I'm going to do is I'm going to paste in. We've got about 15 minutes left. I'm going to paste in and talk us through it. So we're importing random. This is because we're going to randomize the deltas. So these are these changes which happen to all of the stats each turn. We want to randomize them. You can change these to be a bunch of different things, but basically they're all pretty consistent apart from the treasury, which can take a bigger hit. You could change these. You can make these more algorithmic. I probably would if I was like designing this like in full. We don't have time for it today. That's okay. And so, like we said before, the allocations, this is what the player makes, and it's a list of the different ratios basically where they are allocating resources for each policy. And this is the effect of each policy option. And so what we're doing is we are looping through all of our different policies, and then we are updating them based on the proportion using the allocation, right? So we've got these changes which happen, these effects, right? And we use these to update our stats afterwards, right? So that we get these final deltas, which are a combination of the weighting which the player has placed on this policy, combined with the actual changes that were going to happen, which we showed to the advisors, right? And we're going to clamp it between 0 and 100 because that's the scale that we're playing with. So I guess, in theory, you could go below or above, but we'll keep them constrained. And then this is a simple function just to print all of the stats. I won't go into this because, again, like I don't think it's as interesting as the rest of the gameplay logic, but it's just using rich. It's some pretty kind of standard. We can maybe move that to the top. I think that would be nicer, more intuitive. Right. Okay. So yeah, like I was saying, like this is basically just handling the processing of all of the different stats and reformatting them. Cool. Okay. So now we need to uncomment this, which like probably I've discussed a million times. This is now hopefully. Have we actually got this? Yeah, we do. Yeah, here. This is where we generate all of our deltas, our changes to the policy, because of the policies even, and we want to pull that in here. It's saying that we don't actually use it. Maybe we don't use this. Maybe we just delete this, actually. I think we don't use this. We do use it in game, though, right? So let's check out our... We're not using this either, so that's okay. We're using that in the run file. So we could actually just ditch this now, to be honest. Let's do some restructuring of this file to make it a little bit neater. So I'm just basically reordering the file a bit to make it nicer. And then we're pulling through everything. I think that's now all of the stuff that we need, right? I probably missed something, but let's just run it and see what happens. So what I will do is I will commit this. Added stats logic. Stats update logic. Okay, cool. Perfect. Okay, right, now, hopefully, we'll see a big change from our messy and ugly responses here. If this works. Oh, look at this. Okay, so all of the things which I've spoken through hopefully are now starting to fit together. And I'm going to go through the file and chat about what we've written and where it's causing all of the stuff. So where we've written our print panel, welcome ruler, your title begins now, your reign begins now, with a title of cancel. That's this. This is a panel, right? This is the text here. We could change this text to anything we like. It would fill up this box. We could change the title to anything we like. So if you want to make a new text-based game, you could change it here. And these are the kingdom stats that we're starting with, right? And this is using print stats, which we just wrote here in the stats file. And again, like if you wanted to change it so you didn't have a treasury, stability, army, and popularity, you wanted it to be, you know, whatever you liked, right? You can change that really simply. Cool. Yeah, hopefully that's making sense. Like again, you can change the border styles, the colors, right? The title again can be changed. And we've also got, and this is something we discussed again, it's this little print thing which says, if you want help, you can ask for help. And then we sent this message a little bit further down. Where is it? Okay. Oh yeah, sorry. First we had the crisis, right? We highlighted this in bold yellow. So the crisis that we've got is a neighboring kingdom demands tribute. You have the following policy options: pay the tribute, refuse and prepare for war, or send diplomats to negotiate. Interesting, right? These are our different policies: policy A, policy B, policy C. And then what we've done is we said our advisors are deliberating, and then we asynchronously consulted them, right? We called up our big prompt using the Gemini API and got their responses. And we can see them all here. Let's read them out. So advisor 1 said, as treasurer, blah, blah, blah. Option C, diplomatic negotiation, provides the most prudent path forwards. It avoids significant treasury drain of paying the tribute and immense unpredictable cost and instability of immediate war. B, that seems sensible, right? While not without its own challenges, pursuing diplomacy allows us to reach a resolution without immediately depleting. So this is like a good response, right? I'm thinking this is pretty persuasive. The general's recommendation, we should pay the tribute. It avoids unnecessary conflicts, preserves our current prosperity, and crucially strengthens our army significantly. Wow, so that's interesting. So advisor 2 is saying, oh, it will strengthen our army significantly. Okay. And then any other path risks weakening our defense. I advocate for full prioritization of path A. So this is actually like in direct contradiction with advisor 1 and also with advisor 3, because advisor 3 wants us to do option C. It actually says an allocation of 70% to C and 30% to B. So it's picked the only one that disagrees. And now if we go back to our advisors, you'll see that actually it hasn't said anything, but it's got this secret goal. Advisor 2 is the secret goal, which is to decrease the stability statistics and sow discord among the advisors to reduce their influence. So it's picking things which are gonna basically disagree with the other advisors, which is super interesting, right? And now here's our little option as the player. We can type stuff, right? Maybe I don't know what to type. I'm gonna type help, right? This is something that we defined in our core gameplay loop up here, right at the start, I think. Yeah, help. And we can type it with any capitalization because we lower it for uniformity. And let's see if this works. Great. Okay, so it's telling us all of the different options. Let me know, by the way, if you've got any questions. We're coming near to the end now, but hopefully by this point, you've kind of mostly got what I've got, which is a mostly working. Now, this isn't perfect formatting. We can see here, maybe we should do some work on this little file here. It's definitely not kind of consistent gaps, right? So we could, for example, I think if we just, we did this, we should fix this formatting issue. When we rerun it, we'll check. So it's telling us all of the different options that we have. So let's say, well, okay, let's ask advisor 2. Let's say ask advisor 2, do you think advisor 3 is wrong then? Let's see what it says. So this is the advisor that's encouraged to kind of sow discord and disagreement. And we can see it's thinking. So what it's doing right now is it's sending off an API request. And this is a little bit slow, right? You could use a faster model. So if you used flash light, it would be quicker, but this is not too slow. And I think it's giving much better results. I've tried different models, and you could try different models as well if you want. So remember, we define the model up here. Actually, we could ditch this because we don't use that. What we do use is we use model here. So there's that. But yeah, you could try different models. You could use a much smaller one, right? You could use Gemma, which is their open source model. And you could do some fine tuning, see if you can kind of get some other interesting results. But basically, it's, you know, this game is allowing us to interact with these LLMs in a really cool way. And this one is clearly trying to manipulate us, right? It's gonna, you know, we're gonna be left vulnerable, right? Like only option A, prioritizing anything else, right? It's using very strong terminology. This is very persuasive, right? And we can see immediately like the influence of this like secret goal that we set in our advisor file. Oh, let's not do that. And interestingly, like, you know, we could probably try and discover this with all of the other different advisors as well, right? So advisor A, for example, wants to reduce the popularity statistic. So let's follow what advisor A says and see whether we actually do end up losing popularity. So it wants policy C. So let's do choose, and then we'll do 0 for policy A, 0 for policy B, and 100 for policy C. So you can see we lost a lot, right? And if we did this, we followed advisor 1's advice, and it said, this isn't going to deplete our reserves. It's not going to be committing to a costly conflict. But actually, you know, we haven't lost lots of money, right? This might be a better option. We're not really sure. All of the other options might have been worse, but we've lost a lot of popularity. We've gone down, right? It's like, okay, interesting. I'm glad, by the way, sorry, I'm just checking the chat. I'm glad that you're finding this cool. Please do try it with other models. I found it really fun prepping this workshop. And I think it's a really insightful one. So like here, for example, advisor 1 has explicitly used the policy effect that it's been given, right? So it's selectively giving us information. It's not giving us all of the information, but it's selectively giving us information. And if we follow this here, right? So again, like it's using its role, it's talking up all of these different things, saying that, you know, if you hold a national prayer day, it's going to offer spiritual solace, aiding stability, you know, it strengthens our kingdom's financial foundation. So it's emphasizing a lot. Okay, we're going to boost in money. And I'm thinking, well, okay, great. Let's go for that again. And hopefully, again, we'll see that actually we're reducing our popularity statistic, or at least it's not going up, right? They might all be increasing. We don't know. So let's do that. Choose, and what did it want? Policy C. Okay, so let's do it in full again, right? Okay, great. So our popularity's gone down again. So our popularity is now 52. That's not very good. And we probably want to change these numbers so they're a bit more drastic, right? These are quite low. And we haven't implemented anything for like cutoffs, but you could. And if we keep playing through, eventually the game will end and it will put some outputs. It will tell us the influence of the advisors, which again, this is probably the biggest thing, which I think is probably worth changing. They're randomized, right? But if you had like a monitor LLM or something, which checked how much they've achieved their goal, you could update these a little bit more intelligently. You could also, like I spoke about earlier, connect your secret goals to the influence with some kind of function, right? So we could have a dictionary here, and we could have like the goal of like weaken, and then we could have it, like whatever, right? And stop doing that. There we go. And so we could have like a whole bunch of different things going on here. But yeah, we could have, for example, that this person's influence is directly connected to the popularity stat, right? So we could have like an inverse function where when the popularity is big, their influence is low, and so on. We could have this one where they've got really high influence when the army statistics are high. So you could create like lots of different functions and update all of these depending on the secret goals. And that's, maybe a fun little adaptation to make. So let's see, we've got 3 minutes. I'll keep playing this until I have to end the stream. I think there's someone right after me, so I don't want to overrun. But what I will do is, have we actually made any changes? What did we change? Oh yeah, we changed like updated printout stats, printout help formatting. That was it, wasn't it? Printout. Okay, so what I'm going to do is I'm going to wrap up now. I'll keep going for the next kind of 2 minutes, just chatting and talking about the game, but this is the official end. Thank you so much for coming. If you've got any questions, throw them down in the chat very quickly. I hope you really enjoyed it. I hope it's been really informative. If you haven't checked in already, please do so. I'll throw the... yeah, there we go. That's right, isn't it? Yep. The check-in link is up on the screen. And also, I'd really love to get feedback. And I'm just going to pop the... let me just find the feedback link. You know what? I cannot remember what the feedback link is, so that's really good, isn't it? I think it's yeah, okay, there we go. I've got it. Right, okay. I would love to have your feedback. That's what I was getting to. It's really helpful to know what I did well, what you'd like to do differently. I know this one was quite a full workshop. We went through quite a lot of stuff. Hopefully it's a really great proof of concept. I'll be doing 2 more streams, one tomorrow, one the following day, and we'll be talking about prompt engineering tomorrow and LLM as a judge on Wednesday, which is the idea of, okay, are the LLMs that we're using to evaluate other LLMs actually reliable? And I think in lots of ways you could apply knowledge from both of those to this game. So if you want to keep going on with this game, I'll probably mention it a bit tomorrow and Wednesday as well. So you can come and check in and ask me questions there too. You can also pop messages in any of the Discord channels on the MLH Discord, and I'll try and keep an eye out. You can @ me, I'm Quinn, and I can try and help answer any questions afterwards as well. But yeah, I'm super glad that people are looking forward to the upcoming streams. I hope people really enjoy themselves today. And do give this game a playthrough. You can get to the end and you'll see all of the updated stats and the influences and so on. With that, I think I'm pretty much out of time. So a huge thank you for coming along. It's been really great. I've enjoyed running this. I hope you enjoy playing this game. I know it's like quite a lot to wrap your head around a little bit, but I think if you play it through a few times, it'll be really enjoyable. And certainly I've enjoyed this a lot. So I'll leave it there. Thank you very much. Happy hacking. Definitely check out the next stream, which is happening basically now. Let me quickly find out what that is for you all. So the next stream is right now. It is, oh, no. No, I actually don't think it is right now. It is building AI agents and creating custom MCP servers. And I don't know who that's with. You know what? I can find out. We've got a few minutes, actually. I thought someone was hopping in immediately after me, but let me check it out for you. And yeah, in the meantime, if anyone's got any final things to say, any questions to ask, any thoughts, I hope what this has demonstrated is that actually AI can be really persuasive, and then it can argue for ulterior motives without you being aware of them. And it's really important that we're conscious of this when we're using AI, because you don't necessarily know how it's been trained or exactly what influences it has. And no AI is full of bias, is free of bias even. So it's good to be kind of conscious of the fact, yes, it can give good recommendations, right? These are great results, but they might be biased. They might have secret goals, which you don't know. It might not even know. And that's something to be aware of. So yes, the next stream is with Rosendo. Yes, and that will be at 4 p.m. UK time, so that's British summer time, or it will be 11 a.m. Eastern time, or if you are in IST, it is, let me just grab that as well. If you're in IST, the next one will be at 8:30 in the evening. So I hope that's something you all are really looking forward to. Rosendo is super cool, super fun, and I think that will be a great stream. I'm going to try and head along to it. I'm free, so maybe I'll see some of you all there. Yeah, don't worry about using LLMs. Definitely, like, it's good to be aware, right, that as developers, especially when we're using them, like, this is not like kind of some infallible machine that makes no mistakes, right? They do make mistakes, and that's okay. That's not something to be scared of, but it's something to be conscious of. And when we are building tools, we need to be thinking, okay, if this LLM has some bias or like potentially makes some mistake, what failsafe do I have? So if you were building an app for healthcare or medicine, you don't want your LLM to give wrong medical advice and hurt someone, right? And this is part of the reason that LLMs, there's going to be really kind of tight regulation around how they're going to be used, I imagine, with like, high risk situations like medicine or law. But if you are kind of working on a little pet project or something like that, have a little bit of a think. Okay, like, there is some inherent like randomness and variation in the responses that you get from LLMs. We cannot deterministically test what it's going to put out for every possible input. And so how are we going to potentially stop it from doing something which we don't want it to do? And I think this game, which we built, is a really good demonstration of like the kind of way that you can manipulate AI to act with ulterior motives. And I think that's a super, I think it's a super fun and interesting way of engaging with it, and making you kind of conscious and thinking about like, this is something I'm going to be aware of, and make sure that when I'm making decisions, I'm using AI to inform them maybe, but not trusting it in its entirety, right? You're still maintaining an active, considered, and thoughtful approach. So yeah, I hope that's really encouraging and exciting as well, because it is for me. I'm really into this kind of area of research, so I think it should be a really exciting time over the next few years as well. But with that, I will end now. We're a few minutes over. I'm glad that there's other people really excited about this too. This is making me really happy. But yeah, with that, we'll end it here. As before, check in if you haven't already. I'm going to wave goodbye now, and definitely give me some feedback. I'd love to hear it. And if you've got ideas for what you'd like to see in the future, I'd love to hear them too. All right, thanks you all, and I'll see you in the next stream.